Robocat, a self-improving robotic agent. In years to come, in 2026 to 2030, we are going to have robots. Most of the robots we are going to have it implemented in homes, offices, corporate offices, hotels, medical hospitals. So all we need to do is to demonstrate to the robo on what we need to do. We have to give images on the repeated task. Just show them a demonstration in the camera that this is the task that we have to do and just repeat it. Once it's shown, it records itself into the memory and the robo performs the same task. For example, you buy fruits and vegetables and whatever you need required from the shop and bring it to your house. And you need to take the vegetables and put it in your fridge so that the vegetables are preserved for the next week. You just show the robo the vegetables are here and now this is how I pick it and keep it in the different baskets. Once the images are recorded, the next time that you bring up and keep the vegetables over there, the robo will see the vegetables and pick it exactly and put it in the basket that it's required. So the foundation agent learns to operate different robotic arms, which solves tasks as few as 100 demonstration, and there's a lot of improved data. Robots are quickly becoming part of our everyday life, but they are often only programmed to perform specific tasks well. While recent advancements in artificial intelligence could lead to robots that could help in many more ways, in inbuilding general-purpose robots is slower in part because of the time needed to collect real-world training data. Robocat, this Robocat from DeepMind Google has performed a variety of tasks with the different arms and self-generates a new training data so that the robot picks up the real-world demonstration images and performs the tasks. The RoboCat learns much faster than other state-of-the-art models. It can pick up a new task with as few as 100 demonstrations because it draws from a large and diverse data sheet. The capability will help accelerate robotics research as it reduce the need for human supervised training, and it's an important step towards creating a general purpose robot. How a RoboCat improves itself. RoboCat is based on the multimodal Gato. Gato means in Spanish it's called cat, which can process language, images, and action in both simulated and physical environment. They have combined Gato's architecture with a large training data set of a sequence of images and actions of various robot arms solving 100 of different tasks. After this training, the RoboCat is made into a self-improvement training cycle with a set of previously unseen tasks. The learning of each new task follows 5 steps. So collect 100 to 1000 demonstrations of a new task or robot using a robotic arm which is controlled by a human. The fine-tuned RoboCat on this new task/arm creates a specialized spin-off agent. The spin-off agent practices on this new task or arm and an average of 10,000 times, generating more training data. It incorporates the demonstration data and self-generated data into RoboCat's existing training data set. It trains a new version of RoboCat on the new training data set. The combining of all this training means the latest RoboCat is based on a data set of 1 million of real and simulated robotic arms, including self-generated data. There are 4 different types of robots, and many robotic arms collect vision-based representing the tasks a RoboCat would be trained to perform. RoboCat learns from a diverse range of training data, types, and tasks. Videos of a real robotic arm picks up gears, a simulated arm stacking blocks. A RoboCat uses a robotic arm to pick up a cucumber. These are like demonstrations how a RoboCat can work. So it learns to operate new robotic arms and solves more complex tasks. With RoboCat Robocat's diverse training, it learns to operate different robotic arms within a few hours. While it has been trained on arms with true prong grippers, it is able to adapt to a more complex arm with three-fingered grip and twice as many controlled inputs. After observing thousand human-controlled demonstration conducted in just hours, Robocat could direct this new arm enough to pick up gears successfully 86% of the time. With the same level of demonstration, it could adapt to solve tasks that combine precision and understanding, such as removing the correct fruit from a bowl and solve a shape-matching puzzle, which are necessary to more complex control. So the future is robo. Yes.